So in class, we kind of talked about how when you have an inductor and the current is going from A to B, or in this case, B to A, you've got a change in voltage. The change in voltage is always going to be the starting position, which in this case is B, minus the ending position, which is A. And we know that that is equal to L di dt, change in current. Now, they explain that when the current is increasing, then we've got a positive change in voltage, which means that this position is going to be greater. And if it is decreasing voltage, then we get a negative voltage change, which means that the VA would be the greater value. In our scenario, we've got a positive, so we know that this is greater than 0, which means that our current must be increasing and that the voltage at the start is going to be greater. So here, which point has a higher potential? Position B. And then I kind of explained it based on this relationship that increasing, if the change in voltage is greater, it means that the current is increasing, and based on the fact that we have our starting potential minus ending potential, you have to have a greater starting potential. Okay, the current, is it increasing or decreasing? We already established that it is increasing. In order to have a positive change in potential, then we need to have an increase in current. And then here we have to do some calculation. It says the current at T0 is 1.8 amps. So I'm going to call it I naught, 1.8 amps. What is the current at 1.5 seconds? So in this scenario, what we have to do is we're going to go to the fact that we have a change in voltage that's equal to EMF, and that is negative L di over dt. We're trying to figure out this guy, the change in current, and we're given L of 0.43 and we're given change in voltage as 0.78. So di dt is equal to EMF over negative L. EMF is going to be 0.78 volts, and L is negative 0.43 henries. If I take this division, I get 2.73, and that's equal to my change in current over change in time. What I also know, and I can add this in here, is that the change in time is 1.5 seconds. So if I have 2.73 volts over hertz times 1.5 seconds, then I can figure out what the change in current, let's write it like this because that makes a little bit more sense. The change in current is going to be 4.52, sorry, that's the final answer. Our change in current is going to be 2.72 amps from 0 to 1.5, but I want what the final current is, which is going to be the initial current plus the change in current, and then we can add these together. 2.73 amps plus 2.72 amps, and you get 4.52 as the final current.